Okay, so I'm gonna continue with cubic function. This example that I'm doing is example number 6 from your notes on the discussion questions. So we are given the function f of x is equal to 2x cubed plus 2x squared minus 20x minus 28. So the first question there, they are saying that we must show that x plus 2 is a factor. So remember that when we want to show that x plus 2 is a factor, we must take this x plus 2, we set it equals to 0, we solve for x, we are getting x is equal to negative 2, then we take that negative 2 into the original cubic function. And if we get a 0, then it means it's a factor. If we don't get a 0, then we are saying that it's a remainder. It means x plus 2 is not a factor. So if you do this on your calculator, it will give you a 0, hence x plus 2 is a factor. So that's it. That's how you show that x plus 2 is a factor. Number B, they say determine the coordinate, still on number A. They said show that x plus 2 is a factor and hence determine all the factors of f of x. So since we have the first factor as x plus 2, we solve for x here and then we get it as negative 2. We use a synthetic division to get other factors. Remember, how do we use synthetic division? We take the coefficient of x cubed, x squared, x, and the constant in that order. So I'll take the 2, the 1, negative 20, negative 28. And I take the x minus 2 here. I take minus 2. Then first thing that I do, I drop the first value here, which is 2. Then I multiply the negative 2 with the 2. The answer, I write it here, negative 4. Then 1 minus 4, that will be negative 3. Negative 3 multiplied by negative 2, that will be 6. Negative 20 plus 6, that will be negative 40. And then negative 14 multiplied by negative 2, that will be 28. And then we are getting our 0 here. Then it means we are on the right track. Remember, you have to get a 0 here. If not, you know that something is wrong. So we go and rewrite the equation f of x. Our first factor, we know that is x plus 2. And then we use synthetic division to get this part here. And then this part must give you what? A quadratic, and then you continue by solving this part. So this will be x squared, x, and the constant. It will always be like that in that order. So here we have 2x squared minus 3x minus 40. Then we can see that we have to solve for the quadratic part into 2 bracket also. So how do we solve that? I take the first value, I multiply it with the last one. 2 multiplied by 14, and then I get what? I get 28. Then I look for product of 28. Product of 28 can be 1 times 28. It could be yes, 2 times 4, the one that I just did now. 2 times 14, I mean. 2 times 14, what else? 7, 14, 28. 7 times 4. And then from all these products, we check which product can be decomposed into negative 3x squared. I guess you can see that it's actually the 7 and the 4. So I'm going to rewrite the negative 3 into 7 and 4, which is 2x squared. Instead of having negative 3, negative 7x plus 4x minus 14. And if you check from the first the first two, I can take x as a common factor. If I take x as a common factor, I'll be left with what? With 2x minus 7. And then here, what can I take as a common factor? I can take 2x as a common factor. If I take 2, not 2x, 2 as a common factor, then I'll be left with what? With 2x and minus 7. Then we can see that I actually have same bracket. Then I can factorize this into x plus 2 and that same bracket. The x plus 2 comes from this 2 and then this bracket. The aim of this method is to get the brackets the same. So now I can come here and actually say this is factorized into x plus 2 and 2x minus 7. So I factorized the f of x completely. So let's go to number B. Number B, they're saying we must determine the coordinates of the turning point of f. Remember, on the notes, I did specify that when you want the turning point of a cubic, in fact, it also applies to a parabola. I know that from parabola, we learned that when you want the x coordinate of the turning point, we use the equation x is equals to negative b divided by 2a. But still, if you let f of prime x is equals to 0, then you solve for x, you will still get the turning point. So whenever we want the turning point, you must keep in mind that we will do f of prime x and then we let it equals to 0. So what is f of prime x here? F of prime x is 6x plus 2x minus 20. And then we must make this equals to 0. 6x plus 2x, no, 6x squared, sorry, 6x squared plus 2x minus 20 is equals to 0. Then I want to factorize this. How can I factorize this? Okay, I can see that I can actually take 2 as a common factor. If I take 2 as a common factor, I'll be left with 3x squared plus x minus 10. So since my coefficient is more than 1, I can still use this method to factorize. So I will take the 3 and multiply it with the 10. Then I get what? I get 30. What are the products of 30? That will be 15 times 2. That will be 30 times 1. That will be 5 times 6. Then I check which one can I decompose into the middle value. I guess you can see that it's actually 5 and 6. 3x squared. So instead of having the x, I'm decomposing it into 6x minus x minus 10 is equals to 0. And then from the first two, I take 3x as a common factor. I'll be left with x plus 2. And then, is this correct? If I take 3x, I'll be left with x squared plus 2. 6 minus, okay, so here it's supposed to be 5. 6 minus 5x is x. Okay, so I take 3x, I'll be left with x plus 2. And then here, if I take the negative 5 as a common factor, I'll be left with x plus 2 is equals to 0. Then this can be decomposed into 3x minus 5 and then x plus 2 is equals to 0. Then I have x is equals to 5 over 3 and then x is equals to negative 2. Bear in mind that these are the x-intercepts, no, x coordinates, sorry, x coordinates of the turning point. And then you know that when you have x coordinate of anything, we want the y coordinate, we will have to substitute this into the original. So I'll continue with that.